The concept of distribution of mean. The sampling distribution of the mean was defined in the section introducing sampling distributions. A sampling distribution is a probability distribution of a statistic obtained through a large number of samples drawn from a specific population. The sampling distribution of a given population is the distribution of frequencies of a range of different outcomes that could possibly occur for a statistic of population. Before this, I know you have learned a little bit about the distribution of mean. So,
Yes.
who can give me the meaning of mean?
The meaning of mean is mean of the sampling distribution of mean is the mean of the population from which the score was sampled.
Okay, good. The next, can somebody tell me the meaning of variance?
Sir, I want to answer. The variance. Okay, the variance of the sampling distribution of the mean is the population variance divided by n, the sample size. The larger the sample size, the smaller the variance of the sampling distribution of the mean.
Hey you, why are you late?
I'm sorry, sir. I'm from Thailand.
It's okay, I will upload your assignment on Smart2. You can check it later. See ya. So, regarding our assignment, what should we do?
I just bought it from.
Properties of sampling distribution of mean. The mean of sampling distribution of mean is equal to population mean. This is how it's shown.
The standard deviation of sampling distribution of mean is equal to the standard deviation of population mean divided by square root of n. Standard deviation of sampling distribution of mean, also called standard error of the mean. The formula is
Okay, now I'm gonna talk about central limit theorem. What is the central limit theorem? Central limit theorem is a statistical theory that states that given a sufficiently large sample size from a population with a finite level of variance, the mean of all samples from the same population will be approximately equal to the mean of the population. Next, all of the sample will follow an approximate normal distribution pattern, with all variance being approximately equal to the variance of the population divided by each sample size.
Okay, now I'm gonna talk about central limit theorem formula. To calculate Z scores, uh, Z equals to mean minus sample mean divided by sample variance. Also equal to mean minus with population mean divided by uh, sample variance. To find sample variance is variance divided with power root of n. N is sample size. Okay, after that, how the central limit theorem is used in statistics. The normal distribution is used to help measure the accuracy of many statistics, including the sample mean, using an important result called the central limit theorem. This theorem gives you the ability to measure how much the means of various samples will vary, without having to take any sample means to compare it with. Thus, the central limit theorem is also true for other sample statistics, such as the sample proportion. Because statisticians know so much about the normal distribution, these analyses are much easier. Okay, after that, how the central limit theorem is used in statistics. The normal distribution is used to help measure the accuracy of many statistics, including the sample mean, using an important result called the central limit theorem. This theorem gives you the ability to measure how much the means of various samples will vary, without having to take any sample means to compare it with. The central limit theorem is also true for other sample statistics, such as the sample proportion. Because statisticians know so much about the normal distribution, these analyses are much easier.
Okay, the first question is find the mean and standard deviation of x. For the first is mean. The mean is on the spot we can know the answer is 112 from the example. But the standard deviation of x we need to use the formula which is standard deviation divided by square root of sample size. So we put the value standard deviation is 40 divided by square root of 50 and the answer is 5.65685. Okay, the second question is find the probability that x assume a value greater than 113. So x is greater than 113. First of all, we need to change the x value to the z value with the formula x minus mean divided by the standard deviation. And we put the value x is 113 minus the mean 112 divided by the standard deviation 5.65685 and we get the answer is z greater than 0.18. Because of z is greater, so we put 1 in the front minus the z score. And if we refer the z table, we will find out that the z value is 0.5714. So 1 minus 0.5714 is equal to 0.4286.